course, carbon fiber is just a fraction of what carbon provides us. Try to imagine a world without carbon, or even a Champ car without carbon. You can forget about the fancy hydrocarbon-derived paint job. You won't be able to stop without the carbon brake pads. But that's okay, because you can also remove the methanol fuel, the rubber tires, the car body itself, and last but not least, the carbon-based life form at the wheel. Just about everything that counts on this car and in this world is made at least partially of carbon. Carbon is crucial in forming the bonds that make up living things and the stuff that certain living things like to make.
Carbon is the most abundant element in the universe that forms solid structures. Of course, hydrogen and oxygen and helium are more abundant. Carbon forms structures. As a matter of fact, it's a very unique element. It's an enchanted element.
The key lies in the configuration and size of the carbon atom.
What makes carbon so versatile is two things. Number one, the amount of electrons that it has in its outermost shell, which we refer to as the valence shell, is 4. And it's also in the first row of the periodic table, which makes it a very small atom.
The carbon atom's 4 valence electrons bond with larger elements, such as metals, as they give up electrons, and smaller elements, such as gases, as they try to gain electrons. As a result, carbon forms an amazingly broad range of compounds.
In fact, today there are probably over 10 million known carbon compounds.
The most stable carbon-to-carbon bond is found in diamond, a crystalline lattice of pure carbon.
Diamonds have extreme hardness because the carbons that exist within diamond have been compressed under extreme pressure over billions of years to form this interlocking network of tetrahedra. And this interlocking network of bonds between carbons makes this extremely, extremely hard material. In fact, the hardest naturally occurring material known to man.
Carbon, with its unique bonding capabilities, is also the key element of living things. Thus the phrase, carbon-based life forms.
Carbon is an ideal chemical element to be just stable enough to make the stuff of life and the chemicals with which life does business, but just unstable enough that it doesn't cost too much energy to get that chemistry going.
It's this ideal combination of stability and reactivity that makes carbon the backbone of all living systems. With carbon providing the critical bonds, simple sugars become complex molecules like DNA. It's truly the element of life. Carbon-rich plant life of the prehistoric variety has proven one of our most powerful sources of energy. But can we find ways to burn it without increasing global warming?